Okay, so let's do a little video with a simple example, but it'll get the point across. We're going to talk about an object. We can draw an object as a circle or a box, nothing fancy. Could be a car, it could be anything. And that object has a position. Where's the position? Right there. But I need to talk about it mathematically. So I'm going to make up a coordinate system. I could make it up any way I want. I could make it up like this. I could make it like this. But I want to make it something useful. And for this case, I just want to go in one direction. And so I'm going to make a number line. And I can choose right or left to be positive in physics. Often in math, right's always positive, but that's not true. We can talk about position as x or y or z. And we only use x, y, and z pretty much for position. So I'm going to put this and I'm going to say positive x is that way. Now I still can't say, where is it? Give me a number. I could call it 0 and that would be pretty useful. But sometimes that's not the case. So let's just do this. And how long is each of these? I'm going to use that as a long step, or about that, or meter, because we use that a lot. So I'm going to put the units over here. I'm keeping track of everything because I don't want to get confused by my puzzle. I have to look at this. I'll make some mistakes. So let's go here. If that's 0, then this would be -1. Since I have the units over here, I can just put the number +1, +2, +3. You don't need the positive, but it's okay. 4, 5, 6, 7, 8, 9, 10, whatever. If I'd be real careful, I'd measure it. So the position here, I would say, using this system, is that x1 is equal to +3 meters, or just 3 meters. But if I use a different coordinate system, I'm just going to go one-dimensional because the main idea you'll get. And if I call left positive, I'm going to put +x in the direction of my arrow. Let's go ahead and use meters. We could use miles or kilometers or inches or whatever. And in this case, I could put 0 anywhere I want. I could put it in the same place. I could put it in a different place. I don't know. Let me put it. I'm going to line these lines up there. I could really make it confusing. Why not? And in that case, for this coordinate system, I'm going to call this x1 equal to, that's positive, -1 meter. It's the same position though. And sometimes we need a notation to say I'm using this coordinate system and that. Sometimes we'll use prime. There's lots of ways to do that. Don't worry about that. But let's just make that point. So -1, -2, -3, -4, -5, -6, -7, -8, da 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 da. We're just going to go back and forth. This will go a long ways, trust me. So that's where the object is. It's at +3, which is the same as -1 for red and blue. And then it's going to go, let's say, 1, 2, 3, 4, 5. Let's say it goes here. Now there's a movie. If you run the movie, it goes from here to here somehow. It could do anything. I don't know. But if I just have two pictures, or I pause it here and here, I'd call that state 1 and state 2. And then I would say that x2 is, let's see, 3, 4, 5, 6, 7, 8. x2 is 8 meters, or positive 8 meters. But here, that's the negative, and I started here, so I'd say -1, -2, -3, -4, -5, -6. x2 is equal to -6 meters. So I can talk about the position with different coordinate systems and different origins, and my number will be different, but if we mean the same thing, we just have to know that we're talking two different languages, two different coordinate systems. Now let's talk about displacement. Just getting these ideas will go a long ways. Delta x is the change, delta for change, it's a capital Greek delta, from any earlier to any later, is the later position minus the earlier position. It's how you change, where you started to where you ended up. And so this could be from 1 to 2, 1 to 3, 3 to 7, anything. And so it gets easier when you get used to it. In this case, I would say that my delta x from 1 to 2 is equal to x2 minus x1. Now you can do this in your head, but that's the point, is to connect something that you can see the answer and see how the math does it. And then when you can't see the answer, you can let the math do it for you and then check and see if it makes sense. What do I have? I have 8 meters, which is positive, minus 3 meters, which is equal to 5 meters, or positive 5 meters. 5 meters are long steps, maybe 2 steps, in the positive direction, to the right. Blue, positives to the right. Red says, wait a minute, delta x 1 to 2, and I can just make it red, or I can do a prime, is x2 prime minus x1 prime minus 6 meters. And this gets a little tricky. Be careful, because when you make a mistake, it's just so painful. So you want to just go minus a minus 1 meters. That's such an easy mistake, and it's just so frustrating. And on an exam, it's like, oh, I just made that mistake, and then I wasted all my time. So we're learning this really good bookkeeping. It's powerful. It makes things easier. Minus 6 plus 1 is minus 5 meters. And watch what this means. This means to the right for blue, and negative means to the right for red. So in both cases, I moved 5 meters to the right. I just talked about it differently. So the displacement will always be the same, no matter what your coordinate system you use. It's independent. And you'll see that the way I write the equations for constant acceleration motion, I write them in terms of delta x, and it's much better. But the last point is distance. This one's tricky. If you just went from here straight to here, and I don't know, maybe you had a coffee right here or something like that, it doesn't matter, but if you just go straight, stop, whatever, fast, whatever you do, I don't know, then the distance would be 5 meters. And here, your distance would also be 5 meters. You get 5 meters of walking in. Who cares? You don't say, oh, I got negative 5 meters of walking. Distance is always positive. Now, if I do this, if a person went 2 meters and then back, their displacement is 0, but they did 2 meters to the right, 2 meters to the left. That's 1, 2, 3, 4 meters of distance, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 meters. Over here, it'd be the same thing. You went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 meters. Distance doesn't care about your coordinate system, about your positive or negative. Every step counts. You're getting exercise. You're moving. So distance is harder to write an equation for, and we often talk about displacements. I want to know where you started, where you ended up. I don't care how you got there. but sometimes we do, and that's going to be important later to make that distinction. Of course, you'll do exercises like that. So hopefully that gets this across, distance versus displacement. In the next video, let's just do a real short one on what it would look like in 2 dimensions, and then you could go crazy in 3.